Hi, I will be demonstrating reinforcement learning on the L-track algorithms and the various different crash scenarios. The first one is show the V value being updated. So over here we can see like the for the value iteration, the V values are being updated. For the goal state, it's putting the 0.0, and I'm running it for the one iteration, and you can see it on the right side, on the over here like the values are being updated. So you can see it's still running and the values are being updated. I'm running it for the one iteration, um, and we'll be moving to the next one. The algorithm is still running. I'm okay, done. The next one is for the Q-learning algorithm demonstrate the Q values are being updated. So over here again I'm running it for the one iteration, and you can see the Q values are being updated at the specific location for the velocity and the actions basically. In some cases over here we can see like the car is during the training process it is taking the random action as well, and the Q values are being updated for the each cell. So over here I will just scroll it down to quickly show you the iteration. One iteration, its algorithm is still running, and I will just pause it and we'll come back if it is not finished. Yeah, it is finished. The next is for the Q value demonstration for the salsa algorithm. I'm executing it now over here, and you can see like again the algorithm started working, running, and the Q values are being updated at each location uh, and during the each iteration as well. Sorry, it looks like a hang. My computer is hang. I will be back in the minute. Okay, for the salsa algorithm, the execution is completed for the Q value iteration. Q value updation for the one cycle. Here is the output. Now moving to the next one is like the demonstrate the path, state, action, and the state for the triplet and few scenarios. So taking it for the value iteration in the first case. And then in case of crash, it will come back to the original state during the crash. Here I will be I will be printing the first 500 logs, 500 position to avoid the lengthy log during the crash and the iteration process. And iteration will run for the 15 or 20 basically around that. And we can see like after 500 lines, it stopped printing and it is saying like wherever crash occurred, that it is coming back to the original position. I will just pause it and we'll come back in a minute. Okay, so the algorithm execution is completed for the value iteration. I have executed for 5 times, and here is the result set. And you can see like the for each 5 times it took the 10 different 10 steps basically for each execution, and it both are different one basically. So look at over here like this is the initial state and the action taken, and then after it landed to the new state, and this is like a one triplet as requested in the project documentation. Similarly, like the second, it started from the position and then accelerate, and then it landed into the new position. So similarly, there are different 10 steps, and going down like yeah, in some cases I'm it taking the random action instead of the defining the policy. So it total took the 54 steps, and the average is the 10.8 steps for the value iteration. Now moving to the next one is like um, again value iteration, but where in that case car is going to the nearest possible um, position in case of the crash. So now instead of over here again I'm printing like 500 initial log basically print statement is rather than printing the entire log, and whenever crash is happening it is going to the nearest open position rather than moving to the start position, where here you can see the nearest position is the same, but let's move down. Yeah, you can see the different position over here wherever the nearest position happened and crash happened at the wall. So the we can see the both the crashing criteria and where it is starting. Again 500 position 500 printing steps are completed and algorithm has stopped printing it. I will again come back in a few minutes once the algorithm execution is complete. Okay, so the algorithm has completed the execution, the length of the path. In some cases, we can see 12, in some cases, we can see the 11. And again, it's the same pattern like starting position, the action taken, and the new position where it landed. And from that, it started the next position. And it similarly, like total complete trajectory path, how the car moves. Total steps 56 for the 5 different iteration, and the average steps, it is 11.2 for this value iteration. Now moving to the Q learning, I will just start algorithm, and again it is printing the basically it is coming to the returning position. This is for the Q learning. algorithm where it comes to the start position of 5. Again, I'm printing the 500 first log position, and here where it is happening a crash. So now I will again pause the algorithm and we'll come back in a few minutes. Okay, so Q-learning iteration is completed for 500 iterations, and average it took a 196.4 steps to complete the track. Now moving to the next is Q-learning with the crash type, the moving to the returning to the nearest position. Now because of the time constraint, I will be skipping all this intermediate explanation, as well as I will also execute the SARS algorithm where it is original state in case of crash. I will be executing it just now, and the same case I will be executing the nearest position in case of crash for the SARSA algorithm. So again, I will stopping the recording, and I will come back as soon as the all three algorithm execution is complete, and we'll discuss the result set. Okay, so finally all three algorithm execution is completed. So in case of value iteration, it took almost 19.2 steps where it returns to the nearest position in case of crash. For the SARSA algorithm, it took like 130, 140 steps where it returned back to the original state. I just took like 500,000 iteration for this, and this is the basically path you can see over here, the lengthy path for all the steps. And finally, in case of like nearest position, it is taking like 18.6 steps. I took again a 500,000 occurrence sorry iteration, and this is the path we can see over here, the one of the path out of 5 path. That's all. Thank you very much.